So let's now go over example 12.9 out of the textbook. This is the famous case of Compton scattering. So with Compton scattering, what you have is the scattering of a photon off of an electron. Now the photon can't lose speed. Photon is always moving at the speed of light, but what it can lose is energy. And so what we have is a photon that comes in, scatters off a stationary electron, and then afterwards what you have is the photon scattering off at some angle theta, and the electron recoils at some angle phi. So what we would like to find is the outgoing photon's energy as a function of theta. So the initial energy of the photon is E0. The final energy, we want to find E gamma as a function of theta. Okay, so let's take a look. We'll start with conservation of momentum in the vertical direction. I'll call that the y direction. In that case, initially there is no momentum in the y direction. Our photon is only moving in the x direction. And in the after the collision, what we have is minus the momentum of the electron times sine phi plus the momentum of the photon times sine theta. So therefore, sine phi is going to be equal to the momentum of the photon divided by the momentum of the electron times the sine of the angle theta. Now the photon has no mass, so in this case, E squared is equal to P E gamma is equal to P gamma C squared. So what we get is E gamma is equal to P gamma C. So if we plug that in for P gamma is equal to E gamma divided by C. And so the sine of the angle phi is equal to the photon energy after collision divided by the electron's momentum times C times the sine of the angle theta. Okay, so now let's take a look at momentum conservation in the x direction. Okay, so in that case, the initial momentum of the photon is now just the initial energy divided by c, because we said the photon has no mass. So energy and momentum are essentially equivalent, and that's going to be equal to P gamma cosine theta plus PE cosine phi. And cosine of phi is the square root of 1 minus sine squared of phi. And we already said that the sine of phi is related to the sine of theta. So that means we have 1 minus E gamma over PEC sine theta quantity squared square root. Okay. So now we can put that together. So if I multiply this equation up here by C, I would get E initial is equal to P gamma C cosine theta plus PE square root of 1 minus E gamma squared over PEC quantity squared sine squared of theta. Okay. So let's see. And then the only thing I'm missing here is an extra c times the momentum of the electron. Okay, so the other thing we already said was that P gamma is equal to E gamma over C. So I can then rewrite this as the initial energy is equal to the final photon energy times the cosine of theta plus PEC times 1 minus E gamma over PEC sine theta. I'm just going to leave the squared around everything and then taken to the 1/2 power, like so. Okay, so now we want to kind of clean this up some more. So I'm going to move all the energies over to the left-hand side and then square everything. So you have E initial minus E gamma cosine theta squared is equal to PEC quantity squared times 1 minus E gamma over PEC sine of theta quantity squared, close brackets. Okay, now if I multiply through on the right-hand side by PEC squared, I will get PEC quantity squared minus E gamma. I cancel the PEC squared, so I have E gamma squared sine squared of theta. Okay, so hopefully you see where I'm going with this. We now have to square the left-hand side, and so we get E initial squared minus 2 E initial E gamma cosine theta plus E gamma cosine squared of theta. And why don't we add E gamma squared sine squared to both sides? So I get E gamma squared sine squared of theta is now equal to PEC quantity squared. Okay, so this right here just gives me E gamma squared. So now I have E initial squared plus E gamma squared minus 2 E naught E gamma cosine theta is equal to PEC quantity squared. Okay, so that's looking pretty good. So now what we want to do is to look at conservation of energy. So with conservation of energy, the initial energy plus the mass of the electron times speed of light squared. So that is the initial photon energy. That's the initial electron energy, which is at rest. And that's equal to the energy of the photon after collision plus the energy of the electron after collision. And we can write this out now as E0 plus mc squared is equal to E gamma plus the square root of the mass electron squared c to the fourth plus the momentum of the electron times c quantity squared. So that's just the total energy of the electron after collision. Okay, so now what we can do is, let's see, we can do a substitution for the momentum of the electron squared from this equation right up here, and we'll put that into the square root. And so what we're left with is E initial plus the mass electron c squared is equal to E gamma plus m squared c to the fourth plus E0 squared plus E gamma squared minus 2 E0 E gamma cosine theta. So all of this is underneath the square root right there. Okay, so now what we're going to do is we're going to square both sides. So we're going to have E initial minus E gamma. So bring this over to the left, plus mc squared quantity squared is equal to m squared c to the fourth plus E initial squared plus E gamma squared minus 2 E initial E gamma cosine theta. Okay. Now we just square what's in the parentheses. The way I'm going to do that is I will have E0 plus MC squared squared minus 2 E gamma E initial plus MC squared plus M squared C to the fourth is equal to M squared C to the fourth plus E initial squared plus E gamma squared. Wait a minute. Oh, sorry. That's not there. This is E gamma squared. Anyway, E gamma squared minus 2 E naught E gamma cosine theta. Okay, so that means I can cancel these two quantities. I can now work out the square root of this. So then I get E initial squared plus 2 E initial M C squared plus M squared C to the fourth. And then don't forget the other terms, 2 E gamma E initial minus 2 E gamma MC squared is equal to M squared C to the fourth plus E initial squared minus 2 E initial E gamma cosine theta. Okay, so now let's start canceling all of that. The initial squared cancels, the mass squared cancels, and even this term cancels on that side. And so in the end, what we are left with, oh, I'm sorry, no, that doesn't cancel. Erase that. Because that's different energies. Okay, so what we're left with is, I can then, let's see, I can bring all of the E's over to one side, and so I would have 2 E initial MC squared is equal to 2 E gamma E initial plus 2 E gamma MC squared minus 2 E initial E gamma cosine theta. If I now factor out the E gamma, I would have E gamma 2 E initial plus 2 MC squared minus 2 E initial cosine theta. So I can cancel all the 2's right there. And what I get is E gamma is E initial MC squared over E initial plus MC squared minus E initial cosine theta. Okay, so if I divide the top and the bottom by E initial MC squared, I get as an answer a 1 over now 1 minus cosine theta over MC squared plus 1 over E initial. So I now have my equation for the energy of the photon, the scattered photon, as a function of the angle theta, the mass of the electron, and the initial energy of the photon.